Okay, we're going to finish up chapter 20 today, the electrochemistry. We talked about voltaic cells when we get energy, like our batteries. That's kind of your standard voltaic cell. We also have fuel cells. And we know when we burn fuel, we get energy created. Well, we don't really create it. We take the energy that's used there and we convert it to electrical energy. And that's what we did with a voltaic cell. Usually, though, this conversion from burning fuel and getting electricity is only about 40% efficient. The rest is lost as heat. So, and this has occurred a lot in our vehicles. Our engines used to only be like 6% efficient. So moving it up to 40 is pretty amazing. And they get more and more and more efficient all the time. Back when I used to ride a dinosaur, our cars would get maybe 5-6 miles to the gallon, and nobody really worried about it because gas was pretty cheap. Then we had a lot of fuel crisis, and then we were like, we better start working on this. And really, why, if the technology is there, why don't we use it to make sure that our cars are much more efficient? In the long run, it saves everybody money. Okay, so we have, if you take direct conversion of chemical to electrical, that's much more efficient. So again, if you have to burn fuel and then use that to create electricity for movement, it's not nearly as efficient if there's a direct conversion from chemical to electrical. So you don't have that fuel burning part in between. And that's really what a fuel cell is, okay? Fuel cells are not batteries, okay? Fuel cell is a source of energy that's continuously provided, like a hybrid fuel cell, okay? So a battery can store energy. A fuel cell, you have to be continuously providing it, okay? So hydrogen fuel cells is what you'll find like in hybrid cars, okay? In the cell, hydrogen and oxygen form water, okay? And then you can burn the hydrogen, okay? The cells are twice as efficient as combustion. So that's why if you have a hybrid car, like when I had a hybrid car, I got like 45 miles to the gallon, okay? So hybrids, the fuel cells, that's what they do. They're a direct conversion. You don't have to burn fuel and then use it. You have that direct. So the cells will use hydrogen gas as the fuel. They'll burn the hydrogen gas. So what they'll do is they just take, the oxygen from the air to burn hydrogen, and hydrogen fuel comes from, you can see in the cell here. Okay, so hydrogen is your anode. Oxygen's your cathode. Oxygen comes right from the air. They're hydrogen cells, so they have hydrogen in them. Okay, so the hydrogen is oxidized, and you get your voltmeter, and you can see it says 1.23 volts. I don't know if that's the exact there, but anyway, it's like a voltaic cell, but again, you don't have that burning part going in there. Okay. One of the things that a fuel cell will help with, or we could do with a voltaic cell, is because you have this flow of electrons, the anode, the one that's oxidized, okay, you've got this region, and then it goes over here, and where the electrons flow to, the cathode, you're going to get corrosion. If it's iron you're talking about, it's going to be rust, okay? So there's things you can do to prevent that. All right, so again, when you have these cells, you're going to get like this guy over here, your anode is going to get used up and it's going to transfer stuff over here. But because it's transferring oxygen to your iron, you're going to get rust. So again, common name is rusting or corroding. And it doesn't have to just be iron. It can be other things as well. I'm sure you guys have seen corrosion on batteries before. You ever get that when your battery gets corroded on the bottom and then it wrecks your flashlight or whatever, or you got to clean it way out? That can happen, okay? So how do you prevent it? They have something called cathodic protection. Cathodic, I don't know, cathodic. Anyway, protection occurs because the zinc is more easily oxidized, so the metal is sacrificed. So again, at your anode, you're going to sacrifice one but what it'll do is, and again, there's a couple ways of doing this I should show you, okay? So here we put a zinc coating on it. So even though you got water in there and the oxygen, it doesn't corrode. But what's going to happen is the zinc is going to get used up, but the iron isn't going to be oxidized. Okay, the cathode is iron, but it's not going to get oxidized because the zinc is going to coat it. So instead, you're going to get the transfer more to the water, the hydrogen. And because you don't have that transfer of oxygen, you don't get the rusting of the iron. Here's another thing you can do. They do this in underground pipes a lot. They'll have like a connection to a different metal. Here they call it the sacrificial magnesium anode. So the anode is going to be sacrificed. Eventually this is going to wear out, but until it wears out, it's going to protect this pipe, which, you know, is going to be in the soil. It's going to be exposed to water again, which would expose it to oxygen and stuff. It's insulated copper wire here goes to your anode, and then it helps protect it. Once this is gone, you're going to have to replace it. Otherwise, this is going to corrode. Okay, so you can do some things with your anodes or your cathodes to help so you don't get the corrosion. And pretty much it's going to be some sort of like, here we got magnesium, here we got zinc on the anode that's going to have protect it on the cathode side, because the rusting is going to occur on the cathode side, not on the anode. The anode gets used up, okay, because it's the one that transfers over. Okay, here's electrolysis. If you have a non-spontaneous reaction, you can still, you know, most of our reactions we want are spontaneous. We don't have to do anything. But if you have a non-spontaneous reaction in electrochemistry, you can drive it to occur. Okay, here is two examples. We have sodium chloride. So you get your sodium and your chlorine. Okay, your chlorine is oxidizing your sodium because you're going from let me see my reaction here. Yeah, you're going to go from sodium ions to sodium liquid and so on. But anyway, you got your oxidation reduction. Again, anode is oxidation, cathode is reduction, okay? And you might have to add electricity to get this going. Here they have nickel, a nickel one. One of the most common is taking water and you pass electricity through it, electrolysis, and you're going to get hydrogen, oxygen, gas, okay? The bad thing about electrolysis is if you collect the oxygen and hydrogen gas, and hydrogen you use as a fuel, you don't get as much energy out of burning the hydrogen fuel as you had to put into it to get the hydrogen gas. So it's not very efficient. You know, at one time they were thinking that we'd use hydrogen as a fuel, which is a great fuel. It burns clean, no pollution. But if it takes more energy to produce it than we get from burning it, it's probably not such a great idea, right? Okay, so the use of electrical energy to create chemical reaction is called electrolysis. Again, you're going to take a reaction that's not spontaneous, you're going to add electricity to it, and then it's going to happen. And that's called electrolysis, okay? And that's it. We are now done with chapter 20, okay? So make sure you get your work done, and then your next part is a unit test. So one more down.